Well, hello students, how are you all? In our last class, we have learned about the refraction through the parallel glass slab. That as you can see in here in this simulation, that if the light is passing like this, the emerging angle and the incidental angle both are same. And we also proved that in our last video. Today we are going to learn the deviation of ray and the deviation angle. How we can find that? What is the deviation? Let me explain this first. Alright, instead of this, if I take another, let's this prism. Alright, hide this one. We don't need that. So instead of this, we are taking prism. So you must notice that if I keep the light like this in here, the light is actually moving like this and then it is bending up to this situation. So this bending of light or the deviation of light from its main path is known as deviation of ray. All right, so if I show you with white light, see, actually it's making the spectrum of rainbow over here. So this thing is called deviation of ray. But that is just the idea. We have to perform it mathematically. Alright. So as you can see over here in this simulation, we have two mediums. That is, the first one is mu1, having the refractive index mu1. Second one is mu2, where the values of refractive index are given like this for air and glass respectively. Alright, so let me turn on this light first. As you can see, normal refraction is happening. Alright, no issue with that. But what should be the real path of the light if the next medium is absent? That means if I take homogeneous medium, which is nothing but both medium as air, you can see that the light is moving like this direction steadily because there is homogeneous medium, no change of medium occur, so light is moving along that line. But while I change that from air to glass, see, the light is actually bent from the original path. So this making some angle over here, and that angle is known as deviation angle. So what should be the definition of deviation angle? While due to refraction in the medium, the refracted light move from the original path, or you can write deviated from the original path, and that phenomenon of refraction is known as deviation of light. And by which angle it's deviate, it's called deviation angle. So I hope you got the idea about this one, but still we have to learn about this more mathematically. So I will show you two ideas about this one. That is the first one we got over here, from rarer medium to denser medium. I will write it like this: rarer to denser. What happening over here? Let me write it more simply over here. First of all, I'm making the drawing. This is the normal. All right. So light is falling with some angle and it's deviated like this. So light is falling like this and passes through the next medium by refraction. But the light should move with this path. So this is the deviation angle delta, incidental angle I, and refracted angle R. So just think about this. This AB, this is AB right now, this is XY, and this is Z. So just tell me that, and this midpoint is O. So just tell me if XOA is equal to YOB or not. Yes, it is, because both are vertically opposite angles. So we can say both are equal. Alright. Now angle YOB can be break up into two parts, that is angle YOZ plus angle ZOB. So there are two parts as angle we have. Now we have to put the values. XOA, what is that? That is I. Alright, let me put it over here. Angle I, or you can just write I as well. And instead of YOZ, we can write delta, that is deviation angle. And instead of ZOB, you can write R, that is refractive angle. So all we got this relation about the deviation angle delta equal to I minus R. So that is the first case, while we are getting the deviation angle for rarer to denser medium. Alright, so in the second case, we having the first medium as glass and second medium as air. So this is total internal reflection. Let me make it more clear to you. Alright, so we know that when we will pass from denser to rarer medium, then in this case, the ray will move away from the normal, right? So this idea will give you a little bit change of deviation angle. So first of all, let me mark this line should be the path of light. Okay, so how much it's deviated? This is the deviation of light. Okay, the whole angle is R, which is refractive angle, and this is incidental angle I. So let me also draw it over here, that this is the falling light and this is how it is passes. All right, and now this thing should be the light path or the clear path of the light, but it's deviated with this. So this is the deviation of light, and we know that it is I, and the total from here to here is R, refractive angle. Okay, so we got the idea about the refraction from denser medium to rarer medium. All right. Now think about that. Let me just write it with, mark it with the following X, Y, and Z. All right. So first of all, in this case, you can see that delta is less than R. All right. So if delta is less than R, that means if we actually cut it or find the vertically opposite angle, then we can say that AOX, this should be O, that is equal to ZOB. These are vertically opposite angles. So we need to find this angle in the respect of delta and R. And what should be the value? See, the total is R. That means YOB is R. But if you cut that or break that into two parts, in two part means YOZ plus ZOB. That is also equal to R. Alright. So as I told you, ZOB, that is I, and YOZ, that is delta. So this time you got the value, that is delta is equal to R minus I. So it is depending upon the path or the medium crossed by the light. If you coming from rarer to denser, the value will be delta equal to I minus R. But if you coming from denser to rarer, the value of deviation angle will be R minus I. So this thing is all about the deviation angle and the deviation of light rays. In our next part, we will learn about the deviation by prism. So till then, keep practicing. Stay strong.